All right, let's talk about one of the most fundamental forces in the entire universe. It's totally invisible, it's absolutely everywhere, and without it, well, nothing. And I mean literally nothing would exist the way we know it. We're talking about electric charge. So let's kick things off with a pretty big question. What is this hidden property that basically governs our universe? The one that tells atoms how to cling together, that makes lightning crackle across the sky, and, yeah, even powers the very device you're using to watch this right now. You know, the answer is way simpler and honestly more profound than you might think. All right, let's dive right in. To really get a handle on charge, we've got to go right to the heart of what matter is. See, it's not just some extra feature. It's woven into the very fabric of existence. So if you were to look up the textbook definition, it would say something like this. Electric charge is a basic physical property of matter. Kind of like mass, right? But here's the twist. While mass responds to gravity, charge responds to something called an electromagnetic field. And the key word there is force. Charge is the thing that lets matter push and pull on other matter without ever even touching it. It's wild. And this requires a real shift in how you think about it. We usually think of properties as something an object has, right? Like a ball has the property of being red. But charge it's more fundamental than that. An electron doesn't just have a negative charge. An electron is negative charge. You literally can't separate the two. It's what it is at its core. So how does this all work? Well, it's not like charge is just one single thing. Nope. It actually comes in two flavors, if you will. And the way they interact, it all boils down to two beautifully simple rules that, well, they pretty much govern everything. The names we give them are positive and negative. And yeah, those are just labels. We have Benjamin Franklin to thank for those. But the distinction between them is what's so incredibly important. They're perfect opposites. It's this fundamental duality that's just built right into the universe. And that brings us to the first rule of the game. Likes repel. It's that simple. Put two things with the same charge near each other, and they'll push each other away. So a positive charge pushes away another positive. A negative pushes away another negative. It's like this invisible force field between them just saying, nope, get away from me. Then, of course, you've got the second rule, the one everyone's heard of. Opposites attract. A positive and a negative charge, they feel this incredible, irresistible pull toward each other. And this constant push and pull, this repel and attract, it's like a cosmic dance that forms the basis for, well, pretty much everything. But where are these positive and negative charges actually hiding? Where do they come from? To find them, we've got to zoom in. I mean, way, way in. All the way down to the level of a single atom. Okay, so inside the atom, we meet our cast of characters. Right in the middle, you've got the protons. These are our little bundles of positive charge. Whizzing around them are the electrons, the carriers of negative charge. And hanging out with the protons are the neutrons, which, just like their name sounds, are neutral. They don't have any charge at all. They're kind of like the Switzerland of the subatomic world, just staying out of it. Now, here's the thing. In its normal, everyday state, an atom is perfectly balanced. For every single positive proton it has in its core, there's a negative electron zipping around it. They perfectly cancel each other out, which makes the whole atom electrically neutral. It's in this perfect state of harmony. But, as you might guess, the really interesting stuff in physics starts to happen when that harmony gets broken. Okay, so let's zoom back out now and start connecting the dots. Why does any of this tiny subatomic stuff actually matter? Well, because that balance, and maybe more importantly, what happens when you have an imbalance, that's what builds our entire reality. Think about it. When you knock an electron off an atom, suddenly you have an imbalance, right? Well, that imbalance creates something called an electric field. That field then produces a force, and that force, that's what holds atoms together to make molecules. It's why water is wet. It's literally what's holding the chair you're sitting on together, stopping you from falling right through it. And when we figure out how to get a whole bunch of those loose electrons moving in the same direction, boom, that's electricity. It's that simple and that unbelievably powerful. So here's the bottom line, the most crucial takeaway from all this. That simple attraction between positive protons and negative electrons is what holds our atoms together. And the way that charges of different atoms interact with each other, that's what gives us all of chemistry, all of biology, pretty much all of existence as we know it. It's really not an exaggeration to say that this one tiny property is the grand architect of our entire world. Which kind of leaves us with one last big idea to chew on. If the universe is almost always in this state of perfect neutral balance, Just think for a second about the incredible power that gets unleashed when that balance is broken. From that little zap of static electricity you get from a doorknob, all the way up to the absolutely magnificent, terrifying power of a lightning bolt. It all just comes down to charge.